I want to do a shout out to everyone watching, my Patreon members, subscribers, and viewers like you. I really appreciate you coming. Now let's get back to the video. I just got this Commodore Super PET. Does it work? Looks like we got a Commodore repair video coming. Well, as you saw from the beginning of the video, you know this is a repair video. The Super PET computer is comprised of two boards. The first board is the top board here, which is the single boarded Super PET. It is a nicely designed unit that adds functionality to the PET. This has two sockets. One is for the 6502 processor. The next is the 6809 processor, which then allows us to run Pascal and Fortran and a bunch of other wonderful things. It's got a serial port here. It's got its own ROMs on here, its own crystal, its own additional memory on here. And we'll take a look at this next, because in order to get this working, we have to get the main board working. The main board on the Super PET is an 8032. So if you had a Commodore PET 8032, you could buy or get the additional board, pop it in, and now you have a Super PET. In the 8032, it's a 80 column with non-memory is 32K. So it's similar to the 4032. The 4032 PETs have only two video ROMs. RAM. The 8032 has four video chips. They're RAM. They're 2114 RAM chips for video. The difference between this one and a 4032 is just 80 columns, and that's by adding the two additional video RAMs, jumper settings, and the edit ROM needs to be changed. So quick overview of the board. Here along here is the memory, the system RAM. These four chips here is the video RAM. There's the character ROM, the kernel ROM, the edit ROM, and then the three basic ROMs. Now there's two additional empty ROMs. Those are for applications back in the day were created, and you had to put a ROM in here, so I guess help with bootlegging. It's got the user port, tape port, IEEE port, a second tape port. It's got the 6520 22s. Those are for the IEEE ports, a user port, tape ports. There's a CPU card, CPU chip, which is the 6502 running at 1 megahertz. And then we have the 6545, which is a controller IC. It's a CRT controller. It actually generates the vertical and horizontal sync for the 12-inch monitors. Now the older PETs, the 9-inch PETs, do not have this chip, whereas the 12-inch monitors do. So yeah, we got the board hooked up. I've got the PET beside me here. I snuck the cable underneath, plugged the power in. I'm using the PET companion board, which I've developed to give us output, so I don't have to use the monitor in the PET. So just before we start the troubleshooting, I have already repaired this board. It's taken me quite some time. There was a lot of things wrong with it. But what I've done is I put back some of the bad chips, just so we can we can go through and show you what my logic was to find the chips and get them repaired. Now there's a lot of other things that went wrong. This is a timing section for the PET. There was a problem with a couple of ICs here. There's a couple of ICs for the IEEE port that went bad. It looks like this board had a problem where it was subjected to high voltages. I don't think it was through the power. I think it was through the IEEE port because of the damage that was created. It could be that someone had an external disk drive, like a 4040 or a 2040 connected to it, and that had a short of some kind and sent the 12 volts or more through this board, because there are too many chips that have gone bad on this thing to say that oh, it was just, wear and tear and stuff. No, it was a lot of work to get this going. But enough said and done. So let's power it up and see what we get when I first turned it on. And we are getting a chirp, but we are not getting any video. Let's try that again. And this time we are not getting a chirp. So there's some kind of intermittent strange problems happening on here. Nothing. All right, so I think the first thing we need to do, when I'm doing PET repairs, I find that 90 to 95% of the issues is the video RAM. Now, the video RAM chips are 2114 RAM chips, and in the 12-inch PET, the 12-inch monitor PETs, there's 4 of them. On a 9-inch, there's only 2. Now, if you have a 4032, which is built into a 9-inch case with a 9-inch monitor, then you'll only see 2 chips, and then the other 2 are blank. And if you put sockets in the memory, change the jumper settings, and change the edit ROM, you can get an 80-column PET. So this one has 4 ICs. So what I've done, I've actually removed all 4, and I put sockets in. And this is what I generally do when I do PET repairs. Is these are the first things I tackle. Yes, I could use the scope to find out which one is the bad chip and just remove that, but they're gonna go. So I just automatically just socket them and go from there. So let's see first, are we getting any video on here? But before we do that, I'm going to change the 2 bad RAM chips. So I'll get my puller. That's one. Now I'm cheating a bit because the chips I've ever put back have a mark on them. So let's plug in 2 more. So there's another 2142, 2114. Again, make sure the notch is in the right direction. And the 2114. Okay, so these RAM chips are put in. Let's see now, are we getting anything on the screen? We are still not getting anything. So is the problem the RAM? Well, in this case, it is not. It looks like it's trying to power up, and I'm getting intermittent types of screen displays. As we see now, it's a kind of a pattern as opposed to just a blank screen. So the next step would be to monitor the video, see where it's being generated, which is either the issue with the timing of the PET board, the clock, for example, or is it a CPU problem? Is it a controller problem or something else? So let's pull out the scope and take some measurements. Okay, we got the scope powered up. I got my scope cam, which is just the camera pointing at the oscilloscope. I find that a lot of the software that oscilloscopes have that you can capture video, it's great, but it's very slow. So if I'm getting a signal, it takes a while for it to register on the actual computer screen. So I'm just hooking up a webcam to the front of the scope, as you can see my finger there, just to get faster and better readings. So let's pull open this can. Can I get it? They're very tough sometimes. There we go. So in the can we have the timing circuit for the computer. So let's poke around and see what we can get here. Let me hook up the ground. And let's turn on the PET. And yeah, we're still getting the same thing. Let's see if we can get the clock somewhere. And we are getting clock signal here. Let me see this side. And what are we getting here? Let's see if we can do that. 16.1. All right. See, as you can see, I'm pushing here, and I was getting some kind of video, and it was changing. Let's try that. Now we're not getting any video. But we're getting a good clock signal, so that's good. What's the next thing we want to check? Well, the next thing, one second here. Okay, so the next thing is I want to check the, in this case, I want to check the 6545. Now the 6545 is the controller, CRT controller chip. So yeah, let's see if we're getting any video on pin 14. There, sorry, 40 should be a vertical sync, and on pin 39 is horizontal sync. So let's see if that is actually generating any video. So let's go switch cameras a bit here. Okay, now that we have the scope and everything plugged in the center of, sorry, on this side of the screen, you're going to see what I'm seeing on here. So let's poke around, power it up, and we're getting flashes. We're not getting anything. Let's try to power that on again. Sometimes they get flashes, sometimes they get a chirp, sometimes we get nothing. All right, so let's first check pin 40. What's going on pin? Is it turned on? Yes, pin 40 is the first pin right here, and I'm not getting anything. The next is 39. I'm also not getting anything. Let's see if I power it on. I do get a little blip on the screen. Let's see pin 40 again, and pin 40, nothing. It does jump, but there's no video signal at all. So is this getting power? Let's check that out. And the pin for power is VCC's pin 20. So check pin 20. And let's check pin 20. I am getting nothing there. 5 volts. Okay. And pin 1 is ground. Okay. Let's see if we're seeing any other signals. Are we getting anything? I'm just randomly picking pins right now, and I'm actually getting very little to nothing. All right, so what have we learned so far? Well, it looks like let's power that off. It looks like the CRT generation IC, the 6545, is not working. Let me just pull this out. This is the connector for the power for the Super PET. We don't need that for this testing here. Let's put that over there, and let's pull out this chip. So this is the 6540 MOS Technology. They created this. I don't know if it's showing up. Let's see. Can you read that? Anyways, this is the main chip, which is becoming extremely difficult to find replacements. This chip is used for many other things back in the day, but now nothing is using it. So if you can find old stock, best thing to do is get one. I have a couple. I've actually marked this one so we can see, and I'm going to put this one in. There we go. And let's continue on from there. Let's power it up, see what happens. Oh, I am getting flashing. So, all right. So let's check the pinouts again. Are we getting anything on pin 40? Yes, I am getting some signal on 40. Let's check 39. 39. Are we getting anything here? I'm getting noise. And on pin 40, I am still getting noise, but I am getting something. See, I'm just randomly picking on pins now here, and I am getting something. So there's still an issue with the machine. As you can, oh, it's not showing up. Why? On my screen, it's flashing, but on the capture, it's not. So let's try rebooting it again, and still nothing. So what do we do next? Well, the next thing I did was I pulled out the CPU. Let's pull that out, 6502. And I'm going to plug in my diagnostic adapter. It's the PET Diagnostic version 1.6 from Tothmouth software. They don't make this anymore. You cannot buy this little diagnostic board, but they do have a larger board similar to this, which has built-in diagnostics. This is the Romulator, which you can use the diagnostics on this too. But let's just try this one out and see. So I've already changed the switch setting, the dip switch settings for this PET. There's different versions for different PETs, so you have to be careful you put in the correct model number. So let's plug the diagnostic in and see what happens. Oh, we are getting video. Let's switch screens to see what we're getting here. So we are getting some tests. We're getting memories, going through the memory, checking all the RAM. And it's checking all the kernels. So let's, all the ROMs, not the kernels. ROM, D12 is good, is empty, 11 is empty, 10 is basic, 9 is basic, 8 is basic, the next is the edit ROM, and the final one is the kernel ROM, and we got inconsistent CRC. So what does this tell us? Well, this tells us that the kernel ROM is bad. It's having a problem determining if the kernel ROM is correct or not. So let's turn that off. And what we're going to do is we're going to pull out the kernel ROM. Now, if you want to know where things are located on the board, I have created a diagram. I'll show at the end and have a link in my GitHub page where you can get the diagram to show where everything is laid out. So this is the kernel ROM right here. Okay, so let's pull that out and pop in another kernel ROM. The kernel ROM is, it's a MOS technology. It's 901465-22. That is the kernel ROM. So let's plug in the kernel ROM and turn it on. And we're running through our diagnostics again. This is the splash screen, tells you about, you know, what kind of computer it is. IRQ is okay, NMI is good, and now we're going to go check the memory. This is checking the onboard system RAM, not the video RAM. If there's an issue with the video RAM, we wouldn't be getting any video. Alright, so we're checking the first two sockets. So socket 1 is empty, socket 2. This is testing the next one, which is part of the basic. That's good. And the next one here is also basic. That's good. The next one, another basic. Wow, a lot of basics. Then we have the edit ROM, which is good. And now the kernel ROM. Oh, kernel ROM is good. It found it. All right. So, so far so good. We're making progress. We found that the kernel ROM is bad. I've had two video RAM chips are bad, and the 6545 is bad. So far 3 chips. Let's plug in the CPU. And let's power this off first because it's making a lot of noise. Let's pull up this and plug in the 6502. The 6502 is a 1 megahertz. All right, let's power it up. Oh, we're getting chirping. We're getting something. Oh, we're getting a picture. Let me see if I can first sharpen this up. Now on the, what's it called? Let me switch here to, there. All right, so my HDMI board has settings we can adjust. So let's go to auto calibrate. Maybe we can get a better picture. So it's hunting through to see which is the best setup for this motherboard is. All right. Hit menu again. And then go up and. Okay, so we're getting a nice screen. Let's try that one more time. Let's power it off. Let's power it on. We got the good chirp, and we're getting video. Yay! So we're good. Yeah, so that's a great sign. We have computers all fixed, right? Yay! No, we haven't finished testing. We got to test. We need to test that the other RAM is the RAM is detected on this board is showing that the system RAM is good. However, with most diagnostics, this one, you know, Commodore 64 cartridge, Apple II software, I mean, any computer software or, you know, cartridge or board you plug in, the RAM tests are never 100%, meaning that there could still be an issue even though it's not reporting an issue. If you have a device like this, this is my my chip tester pro version 2. This will test for memory also, but you know, again, even with this or any other tool, you never 100% know if the chips are good, because sometimes it says this, you know, this says it's bad and this says it's good. Well, which one is it? I don't know. You'll have to keep, you know, exploring and finding out which one is telling the truth. So okay, great. The next thing I want to do is I'm going to the diagnostics with the well, you know what? Let's plug in the keyboard, see if the keyboard works. All right, I got the keyboard plugged in. Let's power it. Actually, before I do that, I want to plug in my SD to SD to PET. It's a device that allows you to use an SD card to pull data on and off, acting like a floppy drive for the PET. So I've just plugged that in. So let's power it up, and we are here. Yay! Okay, now let's do a catalog. Let's see if we can access. Yes, we can access it. Now the screen is jittery again. I have to play around with my settings. This should be selecting the correct profile, and then you know, I've saved it, so it should be working fine, but the profile for some reason is making the screen jittery. Let's continue. Okay, and then we'll go back. Okay, so it's better looking. Okay, so let's see if we can load something. Let's do a load, and then we'll type in which one. We'll do moon. mon.prg, comma 8. It's not loading. Did you see why it's not loading? Let's switch views here. So we can see we've typed in load. So we'll try it again just to show everyone. Load moon, mon.prg, comma 8. Now look what's showing up. It's doing a search for moon dot the @ symbol rw, which is not what we typed in. So there's still something wrong on this computer. What is wrong? Well, it could be a couple of things. So the main thing is next is we need to check the RAM, because I did replace these 3 chips in the back. These are the 34, what were they, 30, the MC3446. Those 3 ICs were also bad, and it took me a while to figure out that that was part of the problem, and those are controlling the IEEE port. So there's something else wrong. Let us plug in the, so we've already done this diagnostics. Let's run the diagnostics from this board, which is the called a PET test. It's software based and it's loaded on the ROMulator. Let's try that next. Alright, so next thing I want to do is I want to plug in this ROMulator board, and what we need to do is first pull out, where is my, there we go. Okay, pull out the 6502 chip out. Okay, and the 6502 goes in here. Now, while I'm doing this, I know people are going to say in the comments, well, why didn't you check the CPU first? Why did you not check that there's power and reset and all that? And it's like, well, I've already done that. I'm just trying to kind of hurry things along so this doesn't become a 4-hour video and you get to see some of the basic things that go wrong on the PET. Although in this particular PET, the 6545 doesn't usually, it's very rare it goes bad. But yes, I've done all those checks. I've checked the voltages everywhere. I've already checked the crystal on here. I made sure there's no shorts on the board. I was getting the proper voltages from the power supply. I've looked for bad caps. I've looked for anything obvious that's bad. The board was really dirty. And I used rubbing alcohol to clean it, but there was a film on top of all the ICs that I couldn't get off even with rubbing alcohol. So when I was pulling out these RAM chips, the video RAM chips, I used Deoxit to clean the board a bit, and I noticed it was actually pulling off that film. Now, I don't know what this film is, and I don't have a sonic cleaner, so I couldn't clean it any other way. But I found that by using very lightly Deoxit on the motherboard, I was able to get all this crud off, all of it, and there's nothing there, nothing on the ICs. Came out really clean. So I used Deoxit, and I used an old t-shirt that's cotton, only cotton, no polyester or whatever, because the cotton, when you put it down and you go with a brush, it actually will suck up all the dirt with the excess Deoxit, and it cleaned it up really nice. All right, so let's plug the 6502. Oops, pins are bent on here. These are very thin sockets. Okay, let's plug this in. So the CPU goes in this board. I've already set the switch settings to run it as a 8032. So it's going to use the ROM and the RAMs on the board. Let's just see if this works. Yep, and we are getting, let's see if we can do catalog. Okay, and let's do a load. Moon.prg 8. Aha, see now, let me switch cameras for you. All right, so now we can see it's actually loaded the program. So there wasn't an issue with the program. There's something else that's not right with the computer. So moon.prg did a search for moon.prg, and it loaded and it's ready. And if I do a list, we're gonna see a program on here. I don't think this is a PET program. I don't think that this will run on the PET. I mean, if we can run it, but oh, this is Fizzy and Wizzy Go to the Moon. Yes, this is a program that works. Well, it's kind of working on the PET. It works, I mean, on the 8032. It's a 40-column display program. So the next thing I want to do is I'm going to quickly pull out the settings for the jumpers, or the switch settings on the ROMulator, so we can boot up into diagnostic mode of the ROMulator. 1 second. Alright, so the settings is the opposite what I have right now, so it's on, off, on, on. Okay, so let's boot this up now and see if it goes into the diagnostics. Alright, so we are booting up. Keyboard is good, ROM B equals and C equals, so on and so forth. They seem good. I don't see any errors. I'm not sure what those are explaining, but let this run and I'll fast forward a little bit and then we'll cut back to where it's giving us memory checks. All right, now we're down to the last few. And let's see, now it's doing the 32K DRAM test. Let's see if it finds any errors here. All right, as we can see, we have a failure, mem failure. 314,001 is the address, and it's 10. It wrote 10, and it got back a 10, and it got back a 1F. So there's definitely a memory chip problem. So we have to find out which RAM chip that is. There is a picture I have drawn and created. I can share with you at the end with the locations of the memory depending on the address, and then we can replace that RAM chip and see what it is. Okay, here on the side here, there's a chart showing. I just found some information. I kind of made it, more better looking, I guess. I don't know. And it shows you the locations of the ICs depending on your computer. If it's a 2001, 4016, 4032, 8032, whatever, and it shows the location. Now, based on the error, I believe the location is U10. So on the board, if you go look for U10, it's right here. This chip right here. So let's pull this chip out. Pull it out, and we'll put in another test one in here. Let's first check the chip, make sure it's good. So I have my tester. Let's plug in the chip that we just pulled, and we'll run a test. Oops. Select. Let's see if that's showing up, if I can get that on the screen. And test, and it's failed. So that RAM chip is definitely bad. Let's pull that out, and we'll put in a known good RAM, and then we'll run the same test again. Let me just get this nicely on there. Good, it's passed. Okay, so let us now put this RAM. Let's put this 4116 RAM chip in the board and make sure it's nice and plugged in all the way, and we can run a RAM test now. So let's switch things around and we'll get to the test. And we are back. We can see that it's passed, so that error has gone away. We did find that one bad RAM chip, and looks like all the other ones are now good. So let's shut it down, put the CPU back in to remove the ROMulator board, and see if that the loading command works. Let's try that out next. Okay, let's switch screens over here now, and now you can see. Let's try if it works. Okay, so now it's actually loading the proper name. It did a load moon.prg, and it's searching for moon.prg, found loaded. And if we do a list, oops, and we can see that the program is listing. So yeah, this PET board was really a big pain to work on. There were so many things bad with it. The 6545 chip, as we saw, wasn't generating any vertical horizontal sync. That was bad. The 6520s, these two were bad. The 6522 was bad. So basically all the main chips were bad. 6502 was removed, and this adapter plugs in, and this sits on the Super PET board, so it sits here. I put another one here, but for testing. But that was spared, and the 6809 was spared. And yeah, everything's working fine. The caps are original caps. I haven't touched those. So now this part is working. Next would have to be the Super PET side, but I have to still work on that. In the meantime, I have other videos on pet repairs. If you want to watch one of those, that'd be great. We'll talk to you later. Take care.